The paper addresses the issue of state-sponsored disinformation campaigns on Twitter, where governments and affiliated entities utilize social media platforms to shape narratives, manipulate public opinion, and advance their strategic agendas. These campaigns are often conducted by designated troll accounts, which are created by malicious actors and manually controlled to post content and interact with other users. The rise of disinformation campaigns has grown in scale and now operates globally, with over 200 operations targeting various countries taken down by Meta in 2022 alone. The authors identify the need for campaign-agnostic detection systems that can generalize across different state-sponsored campaigns, as past works have focused on detecting accounts belonging to specific campaigns. They present a system that leverages strategies adopted by different state actors to detect troll accounts from previously unseen campaigns. These strategies include sending automated messages, retweeting and sharing selective content, and using fake versions of verified applications. The authors study 19 state-sponsored disinformation campaigns that took place on Twitter, originating from various countries, and translate these traits into a feature set. They build a machine learning-based classifier that can correctly identify up to 94% of accounts from unseen campaigns. Additionally, they run their system in the wild and find more accounts that could potentially belong to state-backed operations. The paper also highlights the importance of understanding the shared characteristics of disinformation campaigns to develop systems that can offer broad-scale generalized detection. The authors note that little work has been done to understand these characteristics, and that various evasion tactics are being used by troll accounts to protect from detection systems and human moderation. This research paper delves into uncovering common themes among disinformation campaigns to develop a campaign-agnostic detection system. Analyzing Twitter data from state-sponsored campaigns spanning 19 countries and over 200 million tweets between 2018 and 2022. The study identifies various techniques used by these campaigns, such as utilizing scheduling services, fake third-party applications, extensive retweeting, and posting innocuous messages. It also highlights potential coordination patterns between accounts from different campaigns. The paper contributes to the field by shedding light on ways to identify state-sponsored disinformation operations, developing a machine learning classifier with an F1 score of 97.8%. And demonstrating the system's efficacy through cross-campaign detection, flagging up to 94% accounts from unseen campaigns. Additionally, it evaluates the system on 2,696 Twitter accounts using fake third-party applications, identifying 116 new potentially malicious accounts and providing case studies that showcase their involvement in disinformation campaigns. The paper is organized into sections, starting with a description of the dataset, which includes information on platform manipulation campaigns attributed to state-backed actors from 2018 to 2022. The dataset consists of data from almost 80,000 accounts in total, with Table I detailing the campaigns and their respective number of accounts. The naming convention used for campaigns is year, month, country, variant. The subsequent sections delve into the analysis of the campaigns, development of the detection model, cross-campaign detection, case studies, related work, and implications for future research. This comprehensive approach aims to provide a detailed understanding of state-sponsored disinformation operations and the development of a robust detection system. This research delves into the characteristics of state-sponsored disinformation campaigns on Twitter, focusing on their techniques and behaviors to differentiate them from genuine user accounts. Utilizing data from the Twitter 1% Data API for the years 20,172,022, the study adheres to ethical standards by removing personally identifiable information and redacting usernames. The paper is structured into two main sections: campaign-level characteristics and account-level features. Campaign-level characteristics involve analyzing tweets across various metrics such as timing, coordination, content, and posting habits to identify patterns shared across campaigns. Account-level features are then mapped to these campaign-level characteristics, which can aid in developing a system to distinguish between real-world users and state-sponsored campaigns. Scheduled messages are a key characteristic of disinformation campaigns, with an average of 30% of messages belonging to one of the scheduling applications. These applications include IFTTT, TweetDeck, DLVR.it, Hootsuite, Twibbble, Social Oomph, and Zapier.com. Some campaigns, like the June 2019 and January 2019 Venezuelan campaigns, post almost all messages from scheduling applications. Retweeting similar messages is another prominent tactic used by disinformation campaigns, with up to 78% of their entire tweets being retweets. Certain messages are retweeted both intra and inter-campaign, suggesting collaborative efforts or a shared modus operandi. Examples of retweeted tweets include calls to follow everyone who retweets or likes the message, a t-shirt cannon, a link to unfollow users, and a link to a website for mass unfollowing. In conclusion, this research aims to understand the techniques employed by state-sponsored disinformation campaigns on Twitter, focusing on scheduled messages and retweeting behaviors. By identifying these patterns, the study seeks to develop a system that can differentiate between real-world users and state-sponsored campaigns, ultimately enhancing the detection and mitigation of disinformation efforts. Detection of state-sponsored disinformation campaigns on social media platforms, such as Twitter, is a pressing concern. This study analyzes a dataset of tweets from known state-backed accounts, identifying distinct patterns that differentiate them from regular users. One such pattern is the use of impersonated third-party sources to post content, which are not publicly available apps and are exclusively used by malicious actors. These fake sources often exhibit spelling errors, leaving spaces, and other subtle changes from the original app source name, making them difficult to visually distinguish. The study also examines the number of sources used by state-backed accounts compared to regular users, revealing that state-backed accounts use significantly more sources to post messages. This discrepancy can be attributed to factors such as the use of different devices or platforms depending on circumstances or contexts. For instance, regular users may switch between mobile applications and web clients, whereas state-backed accounts may employ a range of devices and platforms to maintain anonymity. Understanding these patterns is crucial for effectively detecting and mitigating state-sponsored disinformation campaigns. By analyzing the sources used to post tweets, researchers and stakeholders can identify suspicious activity and take appropriate measures to address it. This research contributes to ongoing efforts to enhance transparency and accountability on social media platforms, ensuring users are aware of the sources behind the content they encounter. This research paper delves into the strategic utilization of third-party applications in state-sponsored disinformation campaigns on Twitter, focusing on their coordination and timing. These applications can simulate legitimacy by posting inspirational content, diverting attention from deceptive narratives and aiding in avoiding detection. The paper analyzes the timing and coordination of these applications across different campaigns, revealing synchronized usage that suggests information-sharing networks or coordinated efforts among state actors. Identical narratives are pushed simultaneously by various campaigns, likely due to aligned geopolitical strategies, economic objectives, or ideological alignments. Successful strategies and tactics are emulated in the realm of disinformation, as evidenced by tweets shared amongst different Iranian campaigns, indicating a common knowledge base. The methodology employed in this study includes a comprehensive analysis of tweets and their associated metadata to identify patterns and trends in the use of third-party applications. This includes examining the types of applications used, their frequency, and the timing of their usage. Visualizations, such as Figure 4, illustrate the coordinated efforts and strategic timing of application usage among various campaigns. The findings suggest that state actors may be utilizing diverse sources to manage their campaigns, including scheduled applications for sending messages that make accounts appear real, and other applications for spreading harmful content. Abnormal activity on fake sources might lead to them being flagged and suspended, so spreading out application use is advantageous. Overall, this paper presents a detailed analysis of the role of third-party applications in state-sponsored disinformation campaigns on Twitter, highlighting their strategic coordination, timing, and stylometry. It emphasizes the importance of understanding these tactics to better address the challenges posed by disinformation in social media platforms. The authors of this research paper delve into an analysis of state-sponsored Twitter campaigns, focusing on their distinct characteristics, behaviors, and strategies. They provide examples of tweets that foster religious tensions between Sunni and Shia Muslims, demonstrating how troll accounts can take both sides of an argument and stir up conflict. The authors identify 7 key characteristics of state-backed operations, including the extensive use of scheduling applications, impersonating third-party applications, leveraging various sources, retweeting similar messages, simulating legitimacy, coordinating timings, and pushing certain agendas. These characteristics are shared across different campaigns and countries, suggesting a level of coordination among state actors. The authors also examine the behavioral patterns of state-sponsored accounts, including their use of impersonated third-party applications, scheduling applications, and multiple sources to post content. They observe stylometric similarities in the posted content, such as retweeting similar messages and amplifying similar content at scale. The authors then translate their empirical findings into account-level features, including posting styles, group activity, and source usage. They prepare a list of 12 signals that capture these characteristics and perform statistical tests to observe key differences between state-backed accounts and benign users. The results show that the differences in scores are statistically significant for all metrics. Finally, the authors outline their approach to building a detection model that can identify state-sponsored campaign accounts from legitimate Twitter accounts. They propose a supervised machine learning classifier that utilizes the extracted features to distinguish between the two types of accounts. The proposed system pipeline involves feature extraction, model training, and alerting relevant authorities to potential state-backed accounts. The system architecture, illustrated in Figure 5, processes 2 input streams: a dataset of known state-sponsored malicious accounts and a set of benign accounts. The system extracts features from both sets, builds a detection model, and identifies unseen malicious accounts. It then alerts users to potential threats and moderates them accordingly. Table 3 highlights significant differences between real users and state-sponsored accounts in features such as fraction of messages from regular sources, cumulative mentions per tweet, and average tweet word count. These differences suggest that certain features can be used to discern between malicious and non-malicious users. Feature extraction is a crucial step in training a machine learning system, where relevant attributes from raw input data are identified and selected to transform the data into a suitable representation for the model. Tables 3 and IV present the differences between state-backed actors and benign users for several features and the complete list of features used to build the detection system, respectively. The features are categorized into 4 main groups: user attributes, account attributes, tweet attributes, and stylometric features. These features include tweet count, account age, number of followers, language, description length, cumulative mentions per tweet, and average tweet word count, among others. The importance of using all these features for optimal performance is emphasized, and the impact of removing certain types of features, such as stylometric features, on the classifier's performance is discussed. Analyzing Twitter accounts to identify state-sponsored activity requires a multifaceted approach. This research examines a comprehensive set of features to distinguish between genuine users and state-sponsored accounts. Behavioral characteristics, such as average tweet frequency, account age, follower and following counts, language, and description language, are essential in this identification process. Additionally, the study incorporates description length, cumulative mentions per tweet, average tweet length, and retweet fraction to capture interaction patterns. Stylometry features, including average tweet word count, unique words, stop words count, punctuation count, word length, sentence complexity, and the function to non-function words ratio, provide insight into linguistic nuances. Furthermore, source features that reveal the origin and nature of content are also considered. By analyzing these features, a classifier can differentiate between state-sponsored accounts and genuine users based on their distinct linguistic patterns, interaction habits, and content characteristics. The integration of these features enables the detection of state-sponsored activity on Twitter, shedding light on the sophisticated strategies employed by these accounts to disguise themselves as genuine users. This research contributes to the development of more effective methods for identifying and mitigating the influence of state-sponsored disinformation on social media platforms. This research paper introduces a novel method for identifying state-sponsored disinformation campaigns on Twitter, leveraging a multi-component classifier that integrates metadata, temporal, stylometry, and source features to enhance accuracy. The classifier is trained using a balanced dataset comprising 500 negative class accounts randomly selected from the Twitter 1% dataset and 500 positive class accounts from 2 high-impact campaigns. The paper presents the performance of 4 different classifiers: K-nearest neighbors, KNN, decision tree, support vector machines, SVM, and random forest, with the random forest classifier achieving the best results, including an accuracy of 98.5% and an F1 score of 97.8%. The system's components are also tested independently, revealing that the metadata classifier performs the best among them, although the stylometry and temporal classifiers perform well individually. The source classifier adds nuance and signal towards prediction capabilities, contributing to the overall performance of the system when all components are combined. The study also evaluates the system's performance with an unbalanced dataset, mimicking real-world scenarios where the class of interest is often the minority class. In this setting, the model's accuracy increases to 99.5%, with a precision score of 99.6%, recall of 99.6%, and an F1 score of 99.6%. Furthermore, the paper addresses structural imbalances in the dataset, identifying differences in the distribution of language proficiency across campaigns and suggesting that campaigns targeting English speakers are more prevalent. Overall, the research presents a comprehensive approach to detecting state-backed disinformation efforts on Twitter, leveraging a multi-component classifier that integrates various features for enhanced accuracy. The findings highlight the effectiveness of the random forest classifier and the importance of combining different components to achieve high performance. The paper presents a system designed to detect state-backed influence operations on social media platforms, with a focus on Twitter. It emphasizes the importance of leveraging multiple modalities, including user-level, temporal, stylometric, and source features for detection. The proposed feature combination is unique and tailored towards identifying influence operations from various state actors emerging from different countries. The evaluation section of the paper evaluates the system's performance when trained on individual campaigns and tested on unseen campaigns. The results show that the system performs well in detecting accounts from other campaigns, with an average detection rate of approximately 94%. However, there are certain campaigns that train the system poorly due to a lack of positive class examples. To estimate false positives, the system is tested on a separate set of real-world users randomly selected from the Twitter 1% dataset. The highest number of accounts flagged is 11 out of 629 when the system is trained on the 2018 October IRA campaign, resulting in an estimated upper bound false detection rate of roughly 1.75%. For the majority of campaigns, the system shows a 0% false detection rate. The paper also explores detection in the wild by searching the Twitter 1% data from 2017 to find messages made from sources popularly used by coordinated campaigns. It identifies 2,696 accounts that posted one or more messages from the application, Twitter for Android, and runs the system to identify accounts. Finally, the paper concludes with a discussion on the limitations, assumptions, and future work, emphasizing the need for continuous improvement in detecting state-backed influence operations. This section of the research paper delves into the analysis of linguistic signals from flagged and non-flagged accounts, employing term frequency inverse document frequency, TF-IDF, to pinpoint key terms that differentiate these two sets of accounts. The findings indicate that non-flagged accounts predominantly utilize generic terms related to daily life, such as si, quiero, vida, hoy, and ia, which are common in social interactions. Conversely, flagged accounts display a higher frequency of religious terms like in, meaning God, in Arabic, suggesting potential exploitation of religious sentiments or attempts to influence religious communities through propaganda or divisive content. The paper also presents case studies highlighting the involvement of flagged accounts in state-backed operations. These include retweeting similar agendas to amplify narratives, create echo chambers, and manipulate engagement metrics. This strategy can stifle open discussions by discouraging genuine users from expressing dissenting views and promoting a desired narrative during significant political events. The provided examples of retweets from both flagged and known disinformation campaigns emphasize themes such as casting suspicion on authority and promoting specific agendas. In conclusion, this section of the paper demonstrates the efficacy of the proposed system in identifying accounts that may be involved in state-backed operations by analyzing linguistic signals and retweet patterns. The findings underscore the importance of monitoring and analyzing social media content to detect potential disinformation campaigns and protect the integrity of online discourse. The authors of the study examined 3 types of messages disseminated by accounts involved in disinformation campaigns. These messages include those supporting the Venezuelan government's stance on COVID-19 vaccines, a common theme among campaigns, as well as pro-Venezuela tweets aimed at spreading specific messages and causing disruptive behavior. The third type involves calls to action, instigating protests, which are considered a key component of disinformation campaigns. In addition, the authors analyze advice messages designed to appear legitimate and gain the trust of the target audience. These messages provide seemingly helpful or insightful information while subtly promoting a specific agenda, targeting users' emotions and aspirations. The authors provide 2 examples of such messages posted by identified accounts. The study reviews related work in detecting fake social media accounts and disinformation campaigns, discussing research efforts that have investigated features commonly found in fake accounts, such as friend-to-follower ratios, posted content, and user behavior. More sophisticated systems using machine learning and data analysis techniques to detect fake accounts are also mentioned, including those that analyze user click patterns, social connections, and synchronized behavior. The authors highlight the distinction between their work and previous studies, noting that their approach identifies features common across multiple campaigns and countries, and utilizes features from different modalities, such as temporal and stylometric features, to capture different modus operandi used by troll accounts. This approach enables the detection of disinformation campaigns across diverse contexts. The generalizability of a system for detecting state-sponsored accounts is explored by training on multiple campaigns and identifying unseen accounts. This builds upon existing work, such as Troll Pacifier, which uses a neural network model to detect troll accounts on Twitter with 95.5% classification accuracy. The significance of disinformation campaigns is highlighted, with social bots playing a key role in spreading political disinformation and influencing political events. Studies by Mihailov et al., Stewart et al., Ratkovich et al., Zanetu et al., and Hagelik et al. Are cited, examining aspects of disinformation campaigns, including account types, behaviors, and content dissemination across platforms. This research focuses on a publicly available dataset of state-sponsored coordinated campaigns on Twitter, revealing patterns in their operation, such as automation through scheduling services and impersonating third-party applications. A machine learning-based model is derived from these findings, capable of identifying accounts from unseen campaigns, marking a step towards cross-campaign detection. The importance of considering disinformation and influence campaigns through a larger lens is emphasized, including potential inter- and intrastate coordination and black markets for reusable political disinformation bots. The resilience of the detection system to evasion is achieved through a multi-factor analysis approach, considering user metadata attributes, linguistic patterns, and temporal behaviors. This reduces the effectiveness of evasion strategies and enhances the system's overall robustness. The implications of these findings for disinformation detection system design are discussed, highlighting the importance of identifying inauthentic account characteristics and informing behavioral models that track account behavior over time, comparing it to established patterns of disinformation spreaders. The authors emphasize the pivotal role of human expertise in refining and validating the output of machine learning models for detecting disinformation campaigns. Combining human analysts' expertise with research insights is crucial to enhance the detection system's effectiveness. Social media platforms must be aware of third-party agencies aiding state actors in mass-producing disinformation, necessitating future systems to counter disinformation that address evolving tactics. Limitations of the study include potential adaptation of disinformation campaigns to counter-detection efforts, which may lead to a decrease in the detection system's efficacy over time. The dataset used has limitations such as the selection process of real accounts for training the classifier and the discontinuation of the Twitter API, limiting the size of the empirical dataset. Future research directions include investigating the mechanisms of coordination and objectives behind disinformation campaigns, understanding the role of platform policies and algorithmic biases in mitigating state-sponsored disinformation, and exploring the impact of shared application usage on disinformation campaigns. The authors acknowledge the support of the National Science Foundation under various grants. Please provide the content that needs to be refined. I'll transform it into a direct, concise form suitable for voiceover narration, maintaining technical accuracy and depth, and adhering to the guidelines you provided. Researchers have extensively studied social media manipulation, disinformation, and bot detection. For instance, Weerasinghe et al. Investigated reciprocity abuse in social media popularity manipulation, while Weinberger and Saul proposed distance metric learning for large margin nearest neighbor classification. The Kolmogorov-Smirnov test, a nonparametric test for comparing two distributions, has been employed in this context. The COVID-19 pandemic has also been a focal point, with WID discussing the problem of disinformation about vaccines and efforts to mitigate it. Wu et al. Presented a method for detecting bots in follower markets, and Shaw et al. Analyzed the self-presentation of a Russian IRA account on Twitter. Yang et al. Evaluated and designed a system for fighting evolving Twitter spammers. State-sponsored trolls on Twitter have been investigated by Zanetu et al., who examined the use of images by these accounts, their influence on the web, and understanding their behavior. Zanetu et al. Also surveyed the web of false information, while Zellers et al. Proposed a method for defending against neural fake news. These studies collectively underscore the importance of developing effective methods to combat social media manipulation, disinformation, and bot detection.